Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to talk about symmetry, especially with respect to the y-axis, the x-axis, or the origin. So a graph is symmetric about the y-axis, if, sketch a little graph here, if on the left side of the axis it's a mirror image of what's on the right side of the y-axis. For the x-axis, it's about the x-axis. What's on top has to be a mirror image of what's on the bottom. And we'll talk about the origin in a moment. But for the y-axis, the way that we check that is we're going to replace x with negative x in the equation. If we get an equivalent equation, that means it's symmetric about the y-axis. So whatever axis you're checking, substitute the other variable, its opposite, and see if you get the same equation. For the x-axis, same idea. We're going to put in negative y for y. Do we get the same equation? If so, it's symmetric with respect, or symmetric about the x-axis. For the origin, we'll come back and talk about that in the next example, but we're going to make both substitutions. Negative x for x, negative y for y, and if they produce an equivalent equation, then it's symmetric about the origin. All right, first, we've got y equals x squared minus 3. So I'm going to check the y-axis first. And that means that negative x is going in for x. So that's going to be y equals negative x raised to the second power minus 3. Negative x times negative x is positive x squared. So this becomes y equals x squared minus 3. That is the same, symmetric about y-axis. Now we're going to do the x-axis as well. For the x-axis, that means that we're going to put in negative y for y. Negative y equals x squared minus 3. Even if we solve for y by dividing through by negative 1, we would get y equals negative x squared plus 3. That is not the same, not symmetric about the x-axis. So we saw the x squared, if all the powers of x are even, when you raise negative x to an even power, you get the same result. So the equation is equivalent. For part B, we've got x equals the absolute value of y plus 5. So again, let's start with the y-axis. Negative x equals the absolute value of y plus 5. That's not the same as what we have above. And if you don't see that, we can divide everything by negative 1 to solve for x. And we get x equals the opposite of the absolute value of y minus 5. Not the same. It's not symmetric when we talk about the y-axis. For the x-axis, however, things are going to work out. When we put in negative y for y, x equals the absolute value of the opposite of y plus 5. Absolute value of negative y is the same as the absolute value of positive y. And that gets us back to the same equation. So this one is symmetric about the x-axis. So just a little summary before we go any further. To check the y-axis, put in negative x. To check the x-axis, put in negative y. Part C, y equals negative 3x, y equals 3x minus 10. If we talk about the y-axis, that's going to be y equals 3 times negative x minus 10, or y equals negative 3x minus 10. That's not symmetric because it's not the same. If we check out the x-axis, negative y equals 3x minus 10, or y equals negative 3x plus 10. That's a no also. So this one's not symmetric with respect to either of those axes. Part D, x squared plus y squared equals 4. That last equation, that was the equation of a line. This is the equation of a circle. And so starting with the y-axis, negative x to the second power plus y squared equals 4 turns into x squared plus y squared equals 4, because again, when we square negative x times negative x is positive x squared. That's the same. This one is symmetric about the y-axis. Then when we try the x-axis, the same thing is going to happen. When we square negative y, we get y squared. X squared plus negative y to the second power equals 4. That becomes x squared plus y squared equals 4, and that's good. So this one is symmetric about the x-axis. So this one's actually symmetric about both of them. In addition, this is one that would be symmetric about the origin, because if we put in negative x and negative y at the same time, we still get the same equation. And that's what we're checking for symmetry about the origin, or with respect to the origin. So in problem 2, that's what we're going to be working with. We're going to put in negative x for x. We're going to put in negative y for y. And we're checking, is the equation equivalent? If so, then it's symmetric with respect to the origin. In the first one, negative y equals 4 times negative x to the second power. That becomes negative y equals 4x squared, or y equals negative 4x squared. That's not the same. So this graph is not symmetric with respect to the origin. That's a parabola. The next one is a cubic function. We're going to learn about those in a moment. But when we put in the two opposite values, negative y equals 2 times negative x to the third power. Negative x raised to the third power is negative x times negative x times negative x. Three negative factors give us a negative product. So negative y equals negative 2x to the third power. And if we divide through by negative 1, we get the original equation back. So this one is symmetric with respect to the origin. If you look at problem C, y equals x cubed minus 7x, really the only thing that's different is that we've added on a term with x in it as well. Let's see if that makes any difference. Negative y equals negative x to the third power minus 7 times negative x. Negative y equals negative x to the third power. We just saw that, right? Negative x times negative x times negative x makes a negative product. And then negative 7 times negative x, that's plus 7x. Is this the same as the original equation? Well, the best way to see that is dividing through by negative 1 so that at least the left side is the same as what we had. Right? That's going to be positive y equals negative x cubed divided by negative 1 is x cubed. 7x divided by negative 1, that's negative 7x. That is what we started with. So this one is symmetric with respect to the origin. Part D, we already kind of know this answer because this is a circle. We talked about this in the last problem. Put in negative x to the second power plus put in negative y to the second power equals 81. When we square each of those, it's going to become x squared plus y squared equals 81, just like what we started with. So this circle is symmetric to the origin. And not all circles are symmetric with respect to the origin, only the ones that are centered at the origin. So again, this is symmetric with respect to the origin. All right, that is it for symmetry. In the next video, we'll take a look at even and odd functions.